Airtightness. Airtightness is key. Airtightness is key to anything to do with passive house. We have to control the environment to which we're in. We need to do it without the influence of drafts or movement of air that we don't want. We basically want a completely controlled airtight environment. Now, when it comes to airtightness, there's a few rules we have to follow, and we're going to cover those as we go through the next few minutes. Controlling our environment. Whenever it comes to any build, there's always going to be some form of air movement. Every junction and connection within a house is going to create some form of air movement, regardless of how well you build. So we have to take care of that in the design. When it comes to the design of a passive house, in the PHPP and in the architectural designs, there's always junction and areas where we need to look at. And it's usually windows, doors, anywhere there's a direct connection. So window and doors, junctions, floor, ceiling, wall junctions, soil pipes, extractor fans, boiler flues, loft hatches, all these penetrations and holes and variances within the envelope is going to be a potential air leak. Okay, what standards do we need to achieve? Well, our standards was 10 originally. Okay. We need to get down to, on a passive house, of about 0.6. So what do these standards mean? What does it actually mean? Well, as you can see here, it refers to air permeability rate per square meter of an envelope area. So basically, we get a box, an envelope, always refer to it as a box. Regardless of shape or size, it's as containment. So therefore, they would measure the square meterage of that environment which we've got to control. And once we've airtighted it, they put in a frame in a doorway, and they will pump air in, or they'll pump air out. There's two different tests they can do. They'll pump air out and suck it out of the building. And once they're down or up to a certain point, they'll then seal the door off, or the fan off. Once the fan's sealed, they will then calculate the amount of air lost over a certain period of time. So what that does is that gives you the meterage, the cubic meters of air that has moved over a given amount of time. So it would be 10 meter cubed per hour meter squared for the area. So that's what they basically mean, is how much square or cubic meterage of air is lost over a given amount of time. So what we need to do is we need to control that. The lower the figure, the better the air tightness and the better the result. There's two different types of air tests. They often do both on a passive house. They do a negative and a positive. So they'll suck the air out, and you can watch all the Intello or whatever your air tightness is balloon in as it tries to suck the air through the walls. And then when that's done and calculated, they'll pump air in and they'll pressurize the building up to the required amount for that build. And then they'll measure that again. And the two together will give you your air tightness. So we want to aim for about 0.6 cubic meters per hour per meter squared. How do we achieve this? We just follow some basic rules. We pay attention to detail. Attention to detail, it just means learning the best methods and how we carry it out. But basically, if we were going to put a piece of tape onto a junction or to a joint, we don't just put it on, we place it. We look what we need to do. We show attention to where we need to put stuff. We pay attention to our overlaps. We pay attention to where we fix the membranes. So attention to detail is key. If you see on the window here, there's a number of areas here which we've taken care of. Is around the window. We've carefully gone onto the window, 8 to 10 mil, and kept it nice and square in the corners. And we've also gone over the brackets was holding the window in. And also we've gone round to the outside, because what we did here is we did the reveals before, so we could get the windows in before we did the internal intello. So when we do a little square in the corners, make sure that's really pulled in tight. And so every area is covered with a piece of tape, but it's covered in the piece of tape in the correct way. It's tight into the corner. There's no gaps. There's no little straws in the intello that hasn't got tape in to let air through. Because if you've got a little tiny pinprick where air is coming through or going out, it's pretty insignificant. But you get 10 of those, it's less insignificant. You get 100 of those, and it's a problem. So what we need to look at is attention to detail. Patience. To have attention to detail, you have to have patience. Taping and airtightness itself isn't actually an extended job. It doesn't take that long once you've got used to it. But not everybody can do it. Many people don't actually have the patience to be able to do this and show attention to detail. They just get, they get bored, or they just don't think that way. So out of about 10 people, I think you'd get 2 or 3 were actually suited to do the airtightness details. Materials. Understanding your materials. What are they? How do they work? Why do we use them? And when do we use them? Do we need a combination of products? These things come with experience and training. Over a period of time, we will be doing more training on materials and how it goes. But understand your materials. Understand that this piece of tape will go on and how it will stick, and how we can go on to with another piece of tape without forming an air leakage in some form. In other words, making sure these corners are tight. We know that the product will do it if we do it in a certain way, because we know our materials. Methods. There are a number of different methods, especially when it comes to penetrations and stuff like that. Understand and look into the methods that you're going to be using to use for your build. An understanding of air movement. Once you get into the train of thought of how does air move in a building, well, we've already spoken about the drafts, potential drafts around windows, doors, junctions and connections in the building. And understanding that once we've taken care of one and we're airtight in one, how the other one may be affected by that. Just understanding airflow. Airtightness is a big part of controlling our environment. We can control this by using an airtightness membrane and tape. Introduction to the materials. Materials. Now, there are many different types of materials that are out there. These are just a few. Intello is the one that you've just seen. It's the one I use the most. But there are many different products out there, and all of these are very good at what they do. The thing is when you use a material, make sure you use the tape that goes with that product. Like it says here, only use the tape which is purposely designed for that particular product, and use it in the correct way.